Muito bom dia, bem-vindos ao terceiro dia do Ciência 2021, o Encontro Nacional com a Ciência e a Tecnologia de 2021. A ciência que faz o amanhã e transforma a economia é o tema da edição deste encontro. O Encontro Ciência 2021 que contou no primeiro dia com 273 participantes presencialmente e 3.070 online e ontem com 287 participantes presencialmente e 1.495 online. Esta quinta Sessão Plenária é intitulada Ciência, Agricultura e Alimentação, desafios para a transição ecológica. Vamos dar início à ação com uma intervenção inicial da secretária de Estado da Valorização do Interior, Isabel Ferreira.
Muito bom dia a todos. Começo por cumprimentar o Sr. Ministro da Ciência, Tecnologia e Ensino Superior, Manuel Heitor, o Sr. Secretário de Estado, Sobrinho Teixeira, a Sra. Presidente da Ciência Viva, Rosalia Vargas, os senhores comissários deste encontro com a ciência e tecnologia e todos os investigadores, cientistas, professores, mundo académico que estão a acompanhar este encontro. É um verdadeiro gosto participar nesta sessão que me é tão cara e começo precisamente por dizer e destacar que uma das mais-valias e uma das mais distintivas marcas do nosso território é a excelência dos produtos agroalimentares que no contexto atual exigem uma forte aposta no desenvolvimento de estratégias baseadas na sustentabilidade, competitividade e inovação. A concretização destas estratégias só é possível quando suportada pelos contributos da ciência e da evolução do conhecimento. São fatores essenciais para a criação de novos focos de investigação, desenvolvimento e qualificação, criando eixos de inovação empresarial e dinamização económica. Esta alteração de paradigma tem, obviamente, de ser aplicada em toda a cadeia, desde a fase de produção até ao consumidor final. Além do programa do Prado ao Prato, esta nova era do setor agroalimentar tem também de estar compaginada com os Objetivos de Desenvolvimento Sustentável da Agenda 2030 da ONU, ou no Pacto Ecológico Europeu, ou no Horizonte Europa. Em todas as fases da cadeia de produção agroalimentar existem desafios enormes, prioritários, carecem de respostas eficazes e merecem a nossa atenção. E por isso vou partilhar convosco e deixar aqui estas reflexões. A primeira é: como podemos conseguir uma agricultura mais resiliente, mais bem preparada para responder às alterações climáticas que provocam horas secas, horas cheias, pragas e doenças, e ao mesmo tempo que aumente a biodiversidade e a qualidade dos solos? Ou como é que podemos produzir mais alimentos acessíveis, seguros e saudáveis e ao mesmo tempo respeitar o ambiente, diminuir a pegada ecológica e minimizar o desperdício? Ou ainda, como é que podemos afirmar clusters agroalimentares geradores de produtos internacionalizáveis e ao mesmo tempo garantir cadeias curtas de distribuição autossustentáveis? Ou finalmente, como podemos apostar em segmentos de maior sofisticação, como os alimentos funcionais ou alimentos dirigidos a grupos específicos, a grupos etários nomeadamente específicos, e simultaneamente garantir a disponibilidade de alimentos em todo o mundo? As respostas também são muitas. Pode ser através da implementação de redes de sensorização, incluindo drones e plataformas de controle e monitorização das diferentes explorações agrícolas, diversificando a produção, recorrendo a variedades mais resistentes, induzindo a sobreexpressão ou a supressão de determinados parâmetros genéticos e fenotípicos, utilizando técnicas de biocontrole, entre outras, ou criando algoritmos de gestão hidroagrícola sustentados em Big Data com informação em tempo real sobre o nível de umidade, stress hídrico dos solos, utilização de fitofármacos aéreos, contaminação dos aquíferos, níveis de produção, níveis de consumo energéticos e hidráulicos e culturas mais apropriadas a cada parcela, otimização do controle de custos, da eficiência hídrica e minimização de impactos ambientais. ou aumentando as capacidades e aptidões dos recursos humanos ligados ao setor agroindustrial, quer para acompanhar as inovações na fase produtiva, quer para acrescentar inovação tecnológica nas fases de transformação e distribuição dos produtos agroalimentares. Ou apostando em núcleos promotores de conhecimento e de inovação tecnológica, à imagem do que já se verifica, por exemplo, em vários territórios do interior, como Elvas, Évora, Porto Alegre, Bragança ou Vila Real. Ou respeitando as tendências mais inovadoras no setor agroalimentar, como, por exemplo, os atuais eixos de investigação em nanotecnologias na indústria alimentar, utilização de biosensores para a avaliação da qualidade e segurança alimentar, por exemplo, ou proporcionando uma melhor articulação do eixo clima, água, energia, alimentos, com forte orientação para o cumprimento das metas definidas na transição climática e energética. Ou fomentando o equilíbrio entre o escalonamento produtivo necessário à internacionalização de bens alimentares e que é de facto essencial para a capacitação económica das regiões, mas também a aposta nas cadeias curtas de produção e distribuição que têm evidentes benefícios considerando o objetivo da neutralidade carbónica, cumprindo as premissas da economia circular com redução de desperdícios e excedentes em toda a cadeia de valor agroalimentar e cumprindo também outros requisitos associados aos conceitos de inovação e de sustentabilidade alimentar. Mas também passa por sensibilizar o público em geral, com particular enfoque nos mais jovens, para os benefícios de uma alimentação saudável com efeitos diretos na promoção da saúde. Ou apostar nos alimentos funcionais, superalimentos, nutracêuticos, o que se consolidará como uma nova mais-valia com grande potencial para os produtores de bens alimentares. Ou desenvolvendo novas embalagens alimentares, produzidas com materiais mais sustentáveis, que cumpram não só o objetivo principal de acondicionamento do produto, mas possam também transmitir informações diretas ao consumidor final e que hoje são procuradas, por exemplo, o estado de conservação do alimento, no conceito Smart Packaging. Ou estabelecendo novas fontes proteicas, leguminosas ainda não exploradas, algas, insetos, que possam aliviar a pressão produtiva das fontes animais e com benefícios para a neutralidade carbónica. Ou desenvolver novos produtos alimentares decorrentes de parcerias profícuas entre instituições de ensino superior, entidades de interface científica e tecnológica e empresas. Promover os produtos com menção de qualidade, os DOP, os IGP, através de iniciativas de âmbito nacional, envolvendo também o setor do turismo e, naturalmente, a academia. Mas também pode ser implementando estratégias de diversificação produtiva com possibilidade de inclusão de novas espécies, especialmente pelo melhoramento das condições agronómicas, com maior disponibilidade de recursos hídricos, tornando as regiões mais resilientes. São múltiplos os desafios e as respostas, mas a rede de unidades de investigação e desenvolvimento existentes em Portugal, que é tão diversa, que tem as instituições de ensino superior, os centros de investigação, os laboratórios associados, os laboratórios colaborativos, constituem o ecossistema de inovação ideal que proporcionará este efeito transformador no setor agroalimentar, criando dinâmicas regionais mais eficientes e proporcionando resultados sinérgicos, quer ao nível da maior rentabilidade da cadeia de valor, através da incorporação de inovação em toda a linha de produção, quer na validação da excelência dos produtos portugueses e as suas menções de qualidade, ou o desenvolvimento de produtos inovadores, como falava há pouco, os alimentos funcionais, superalimentos, nutracêuticos, ou processos produtivos que respondam ao atual nível de exigência dos consumidores. Nesta fase de transformação, de produção, o respeito pelos princípios da economia circular é fundamental, pelo que qualquer iniciativa de inovação produtiva tem que garantir a sustentabilidade em todas as fases de produção, maior durabilidade, reutilização, capacidade de atualização e reparação de equipamentos, eliminar a presença de produtos químicos potencialmente perigosos e aumentar a percentagem de materiais reciclados sem prejudicar a qualidade do produto, maior eficiência energética, utilização de material adequado também para posterior reciclagem, contribuição para a redução da pegada carbónica e ambiental e utilização de materiais e equipamentos que não se tornem rapidamente obsoletos. Mas também obedecer à circularidade nos processos de produção, que deve ser evidenciado que a adoção deste conceito representa meio caminho para a geração de valor acrescentado, através da integração das melhores técnicas disponíveis no que concerne às práticas de economia circular, promover a simbiose industrial, utilizar tecnologias digitais para rastrear, monitorizar e mapear recursos, implementar sistemas de validação para avaliar a incorporação de tecnologias verdes ou processos de certificação. E no âmbito do setor agroalimentar, estas questões assumem especial relevância em virtude da União Europeia ter considerado também no seu plano de ação da economia circular os alimentos, água e nutrientes como um dos setores de intervenção prioritária. Por isso, em conclusão, o eixo agricultura-alimentos pode, e tenho a certeza que beneficiará em grande extensão, da incorporação de tecnologia, ciência, inovação produtiva, atingindo níveis de excelência nos seus produtos, valorizando e promovendo o que de melhor têm os nossos territórios e estreitando a interface entre a atividade científica e o desenvolvimento socioeconómico. Esta é, de facto, a melhor altura para robustecer e rejuvenescer o nosso setor agroindustrial, com recursos humanos altamente qualificados, preparados, consolidando o potencial dos produtos alimentares através de uma completa adaptação às atuais exigências de mercado e, assim, catapultar a qualidade dos nossos produtos a nível internacional e alcançando novos patamares de dinamização da atividade económica. A ciência é a chave. Bom trabalho a todos.
Segue-se um debate que será moderado por Rosalia Vargas, Presidente da Ciência Viva, que chama ao palco. O painel é composto por Vitor Espírito Santo, Diretor do Departamento de Agricultura Celular da Eat Just, James Taylor, Diretor de Investigação do Institut National de la Recherche Agronomique, Teresa Pinto Correia, Coordenadora do Laboratório Associado Change, o Instituto para as Alterações Globais e Sustentabilidade, e Gabriel Marais e Nuno Ferreira, do Laboratório Associado InBio e da Associação BIOPOLIS, e também Carlos Faro, diretor do Biocante. Passo a palavra então à Presidente da Ciência Viva, Rosalia Vargas, para moderar o debate.
Good morning. I will speak in English because we have translation in this room but not online. Well, I'm very, very happy to be chairwoman in this panel about such an important topic, science, culture, agriculture and food, which is part of our daily lives, plus the urgency of challenges for ecological transition. It will be very easy for me to moderate this debate because the essential thing is to let our speakers speak. But the difficult thing is for them to do so in the time that is always short for that they know about issues that are at the heart of R&D in food, health, well-being, among others. The challenge comes from what these great speakers and these great themes bring us in innovative and up-to-date knowledge. I would like to thank you for your presence in this auditorium and also for those who is following us by online. And in these 2 days of this meeting, we had almost 5,000 people following us by online. So, good morning, Teresa, Pinto, Correia, from the University of Évora with the Change Project, Gabriel Marais from CBU, with the BIOPOLIS project, Carlos Faro with the biotech food, and online we have James Taylor. Hello, good morning, how are you? James is based in Montpelier and will bring us his expertise in precision agriculture, especially in the vineyards. And we will have also Vitor Espírito Santo, bringing us a research in artificial meat and how we as consumers can eat just. Well, it's time to go to our speakers, starting by Vitor Espírito Santo. He is now in San Francisco, and now it is around more than 1 o'clock in the morning. So he sent us a video, but it's a video of 20 minutes. But it's so challenging to see this video that I ask your attention. We asked the speakers, don't speak more in the first intervention, more than 15 minutes. But Vitor, he has 20 minutes of video, and I asked to put the video first of all, and I ask your attention. Thank you.
First of all, good morning, everyone. I would like to thank the organization for the invite for this meeting. I think it's a wonderful lineup, and I would love to have been in Portugal to be present in person, but the circumstances this year are particularly difficult with the pandemic and all the traveling. So I hope we can still make it work for an interesting presentation remotely. So my goal for today is to really introduce you on the topic of cultured meat and tell you a little bit about the progress that we have been doing here at Eat Just, the company that I work for. So my role in this company is I am the director of cellular agriculture. So the company is a food company in San Francisco in the United States that has already a history of successful products in the market, but that has more recently, over the past 4 years, really focused on the development of these cultured meat approaches that I'm gonna introduce you a little bit more today. So starting off with the definition of meat, I think that us as Portuguese, we have a high consumption of meat. It's part of our culture and diet. Meat is essentially the flesh of an animal that is used as a food product. It's an animal tissue that is considered as food, and it can be either a more structured product, like an intact cut of meat that is more premium, or it could be also considered more like a processed type of food, like a burger, a patty, or a sausage, in which the meat is a little bit more processed and it combines different parts of the animal. So the conventional production systems comprise essentially of two major categories. So you have the organic animal farming, that I would say is the oldest one, in which you have a sort of a slow production with few animals, and people would produce locally almost for their own consumption. But obviously, due to our industrialization and growing number of population, this is no longer the dominant production system for meat these days, and it's much rather intensified, as you see in this picture. And essentially, in order for us to meet the demand for consumption of animal protein, we need to raise millions of animals in extremely confined spaces. So in order to really produce the quantities that are needed to feed the entire world. So this raises a lot of challenges, because even though we are already at what we consider a very industrialized and maximized production capacity, that might still not be enough. When we look at the numbers in this graph, you see that the consumption of animal protein in the world has been increasing consistently. And there are even some worrisome trends, like the red graph, or the red line in this graph, that is the China case, in which a country that didn't have a strong history of consumption of animal protein is changing their habits and essentially consuming a lot more than in the past. And this is associated with the development of the economies and essentially a bigger percentage of the population in the so-called middle class. So by 2050, we are facing a very difficult challenge of not being able to supply the animal protein that is needed to feed these populations. In other parts of the globe, like the US and Europe, we have a more steady increase, but it's still an increase. So the demand is only going up. So besides the limitation in the supply, this also raises significant questions when it comes to environmental impact of conventional meat production systems, and also some ethical concerns, especially when we think about animal welfare and looking at the pictures that I just shown you, in which the animals are really not raised in their best conditions, and the meat quality is then obviously decreased. Another very important aspect is also food safety. So food safety is a concern. We are living a pandemic that was essentially generated by zoonotic disease transmission. So meat production systems, the conventional ones, are certainly one of the roots for these pandemics. And this is something that we have to take into a lot of consideration. So how can we develop an alternative to our current system? Cellular agriculture offers some possibilities here. And what is cellular agriculture? So cellular agriculture is essentially, as the name says, a production of agriculture products through cell culture and through cells. It can be done by the application of the entire cell in the finished product, like the type of products you see on the left side of this slide, like meat or some clothing options like leather, for instance. And then you also have cellular agriculture being applied to a production of acellular products, in which we are more interested in what the cells are producing rather than the cell itself. We have been doing this for several decades, both for the food industry and for the biotech space. So if you think even, for instance, of diabetes treatment with insulin, insulin is produced through a genetic modification of the bacteria or yeast that is then producing this protein that is used in treatment. So essentially, these applications have been around for many decades and are regarded as safe, granted that they follow certain protocols. So going a little bit now back on what is cultured meat and what has been the history. Cultured meat is a relatively new concept, but it has been firstly mentioned by Winston Churchill in 1931. And he made this very interesting statement back then, in which we shall escape the absurdity of growing a whole chicken in order to eat the breast or the wing by growing these parts separately under a suitable medium. So he already had essentially designed, I would say, the concept of cultured meats, in which we are replacing the conventional production system by growing just the animal cells that are used in a meat product by animal cell culture technology, just focus on the edible parts. So this idea didn't really take over because animal cell culture technology was not as developed. So throughout the 20th century, there were a couple of important people that really pushed for this technology. William Van Illen was one of them. He really tried to make this happen during his lifetime, and he wrote the first patent, and he tried to really push for research in the Netherlands. And he got some established tissue engineering scientists to really work in this project. One of them was Mark Post, And actually Mark Post back in 2013 created the first prototype beef burger that you see in that picture that is essentially made of muscle cells. It cost 250,000 euros to produce. And, you know, it was made public through a public tasting in London in that year. And it was it had a pretty positive feedback. So essentially the taste was very similar, a little bit more dry, but it really showed that this could be done. The price was prohibitive, but it was just a proof of concept. So ever since, there's been some push in the industry to really develop cultured meat products. And companies like Eat Just really focused on making this happen and making it happen at scale. So for the past 4 years, we have been developing cultured chicken, cultured beef, cultured pork. And we are very happy to announce that last year we got the first worldwide regulatory approval for commercialization of cultured chicken in Singapore. And after the regulatory approval, we started selling the product in restaurant services and distribution services as well since December. So this has been a very important milestone for the entire field. So what is essentially meat? Meat is a mixture of different cell types that really make up for the organoleptic and sensory experience that we have when we eat meat. So muscle cells, fat cells are all embedded in this sort of extracellular matrix that provides the three-dimensional structure. And that's what we're trying to replicate here. And for that, we're using cell culture, which is essentially, applying a lot of common concepts used for biotechnology and biopharmaceuticals, in which, for instance, from a small biopsy of cells that are taken from the animals, we can then expand those cells by feeding them with nutrients that contain a lot of the amino acids, proteins, sugars, vitamins that are needed for the cells to divide and be healthy. And essentially we grow then these cells in also these incubators, which essentially mimic the animal body condition in terms of temperature, oxygenation, in terms of mechanical stimulation. So that's how we get the cells that we isolate from the animals to grow in these sort of culture devices. And that's what we have been doing at Eat Just. So as I was saying, we have gotten the first regulatory approval back in 2020. We have now a brand that is called Good Meat, that is essentially a subsidiary of Eat Just. We have recently received officially a funding of $170 million for the development of this technology in our most recent fundraising. And this technology, since the regulatory approval, has really taken off in terms of attention worldwide and in terms of interest from private funding. So I think this is also something very important to take into consideration. And what we do at Eat Just in terms of technology is very similar to what I was just saying. We isolate cells from different animals, from different breeds. Then we go through a process of cell line selection in which we look for the cells that are more powerful and better from an organoleptic and sensory standpoint. And in parallel, also good performers in a cell culture setting. And we're focused on the major categories of cells like muscle cells, fat cells, and connective tissue that together make up for the most important cell types that are present in meat. We no longer work only in small scale. We have been producing in large scale bioreactors for a while now, and even the scales that we have right now are not enough. So we are in a continuous process of producing these in larger tanks. And this is what you see here in this picture. So the bioreactor on the left side is a stir tank bioreactor, a stainless steel with volumes of 1,200 liters. And essentially, that's where we culture the cells in this cultured media that contains the nutrients. And at the end of the process, you have a very dense broth with the cells in high density, chicken cells, that then we have to concentrate and remove the sort of residual culture media that we don't want in the finished product. So what you have is a sort of a ground chicken product like the second picture from the right that is in that plastic bag that has an appearance that is very similar actually to cultured chicken, but in the ground shape. And from this ingredient, let's say, we then can make a lot of prototypes. We can make cultured chicken bites, but also we can make more structured products like cultured chicken breasts, like the one you see being grilled on that picture that already has a much more fibrous and three-dimensional structure that is expected from, a three-dimensional meat cut. One of the main advantages of this product is its microbiological composition, specifically the lack or very low concentration of microbes. Specifically, when you compare our production data with a conventional chicken in the US, you see a very significant difference. Specifically, the important fecal matter and salmonella, the bottom two rows, raise critical aspects of food safety. And one of the reasons why we can have a very low content of microbiological composition is because cell culture is done in a aseptic environment. That's one of the criteria for us to achieve a successful animal cell culture production. And the beauty of this is that we have accomplished this without using antibiotics. So this is one of the major achievements that really demonstrates the advantage of this technology. And when we look at the nutritional value, it's very comparable to conventional meat. When we look at the essential amino acids that are provided, types of proteins, fats, and minerals, it's a highly nutritious product that is comparable to conventional meat. In terms of consumer demand, why are we doing this? Why are we not just going, let's say, for a plant-based alternative replacement? Cultured meat combines the best attributes of conventional and plant-based meat because it really captures the top reasons why consumers eat chicken and beef, which are taste, and then plant-based meat, which are maybe health considerations, environmental and animal welfare. We are addressing these key concerns without sacrificing taste. So as I was saying, in terms of safety, we're not using antibiotics, but we're improving the safety profile of our finished product while keeping higher levels of sustainability and animal welfare, as we don't have to sacrifice animals to produce cultured chicken. It also provides a lot of environmental and social benefits. As we're moving from livestock to cultured meat, we're reducing, lower CO2 emissions, and there's no deforestation happening. And we're reducing animal suffering, and we're providing safer working conditions and supporting food security. And it is also clear evidence of consumer interest to purchase and substitute conventional meat for cultured meat. From our own data from surveys in the US and Singapore, we have seen that 91% of restaurant operators are open to selling cultured meat, and of which 82% of them envision cultured meat replacing all conventional meat in 10 years. And 2/3 of the consumers are open to substituting conventional meat with cultured meat, and 75% of the consumers are likely to substitute plant-based meat with cultured meat. So this showcases that we're not targeting a specific niche, we are actually targeting a much broader consumer group that includes conventional meat eaters. This is a picture of our cultured chicken bites that we have been selling since December last year in Singapore in restaurants and delivery services. These are some pictures from the launch in which we had a few groups. One of them was this group of students, very young students with this sustainability interest that were really impressed by the whole experience. And as I said, we've created this brand, Good Meat, that has been growing over the past few months. And the product is now also available in delivery services in Singapore through this app in which you can order cultured chicken that is served in different dishes, like the one present in this picture, and is also, obviously targeting an Asian market right now. So the types of dishes that we offer include like chicken with rice and salads, but also dumplings, which obviously are very appealing for an Asian consumer. In terms of sustainability and food safety angle, and just to wrap up the presentation, as I said, I think I demonstrated that this product can present a lot of advantages, especially when antibiotic overuse in animal agriculture is a ticking time bomb that can compound the problems we face with viral pandemics, as the one we have been dealing for the last 2 years. And livestock health is the weakest link in our global health chain. And if we look at actually considerations from the United Nations Environment Program, we see that increased demand for animal protein and unsustainable agricultural intensification are listed as the top 2 major anthropogenic drivers of zoonotic disease emergence. So this is something that we have to really pay attention to, and it's not something just to look into a far-fetched future, but it's something that is really happening as of today, and we need to take action. As I mentioned also, from the studies that are available, we can really improve the sustainability by applying this cultured meat approach. So we're growing meat directly in a controlled environment and without byproducts like bones and feathers. So it's way more efficient, and also reducing by 92% the CO2 emissions, 95% land space, and also 78% less water. And we can definitely make a much more efficient from an energy standpoint product. When we look also at animal health, so right now we are producing cultured chicken from a cell bank of chicken cells that we have developed over the past few years. So we don't need to go back and perform additional isolations over and over again. So essentially, we don't need to sacrifice more animals. Not a single animal has actually been killed to develop this process. And from a single cell, we can make unlimited supply of meat. So essentially, this can really change the way and disrupt the way that animal production systems are happening these days. And we have talked with international producers and big brands that have shown a lot of interest in following this approach, and really shows that the field is paying attention to, and that we should take this into consideration. So first of all, I would like to thank you all for your attention. If you guys would like to get a little bit more information about what we do, please feel free to reach out by email or by LinkedIn through my profile, and I'll be happy to address your questions. Thank you so much for your time.
Thank you very much, Vitor. Well, we can say that we are entering in the new era with the meat technology, good meat, very soon maybe in a restaurant close to you. Well, I would like to ask James Taylor, he is online, and to take the floor with us. James, please, good morning again.
Good morning. Thank you very much for having me. Okay, perfect. So, well, thank you for the invitation to talk today. The work that I'm presenting, I do in collaboration with Bruno Tisser. We work within a mixed research unit, so it's between INRAE and the Institut Agro at Montpelier. And Bruno is the professor of precision viticulture, and I'm a research director in the area of digital agriculture, precision viticulture in France. So my talk's going to be slightly different to Victor's. I'm going to not talk so much about technologies, but some of the challenges and some of the issues that we have thinking about how we get translation in this area. So first of all, lots of robots are coming. There's lots of things that are happening, very exciting, great stuff. I love it. Drones are part of that, how we actually collect information. The sensors that we have at our availability nowadays is fantastic. We can measure all sorts of different things on all sorts of different platforms. So the technologies are there, but I won't talk too much about that today. What you can see is in this area of digital viticulture, precision viticulture, the amount of research is just growing and growing every year. So in the last 20 years, we've gone from not having this idea of precision viticulture, digital viticulture, to having 50 odd papers a year being published, predominantly in the big viticultural countries, Spain, Italy, France, Australia, the US, and of course Portugal. And there's a fantastic precision viticulture, digital viticulture group in Portugal, particularly several of them, but particularly the one led by Marais. He does fantastic work. So we are progressing and doing things. And the area that we work most in seems to be in mapping vigor, mapping canopy, using satellite systems, proximal systems, terrestrial systems, UAV systems, but looking at how vines grow and how that relates to yield, how that relates to quality. Lots of research in this area. And as I said, the drones are coming, the robots are coming. So we're starting to see more and more research being published into these areas. And the UAVs, of course, are dominating the sensing, the canopy sensing nowadays. But, you know, these are just sensors, these are just platforms that generate data. And what we're really interested in and what the real challenge is who makes decisions. And that's the tricky part. Who makes the decisions and how do we translate this into the industry, into use? And if we look, again, this is just a look at how many papers are published using the term precision viticulture and decision support into the scientific literature in the last 20 years. Almost nothing is being researched or being actively done in developing decision support systems that take advantage of digital viticulture and precision viticulture. So we work on the technologies, we don't work on the decisions so much. We certainly don't publish into the decisions so much. And that's what happens when we end up with this sort of this gap in the middle of these technology readiness levels and the translation from great academic public sector research and excellent science. And then we have all these wonderful companies like Victor's that we just saw, who are developing commercial services and commercial enterprises. But we need to be able to connect them effectively if we're going to enhance the transition, particularly to ecological agricultural systems. And to do that, we really need to have both infrastructure and we need to have capacity in people. So we need platforms that support this, but we also need the people that are capable of working in this area. And it's quite a diverse area. So it's quite a particular speciality of people that you need in this area. As a precision agriculture community, we tried to address this for the last 5 or 6 years. This is not a football score. This is actually the number of papers that were presented at the really big European conferences on precision agriculture that relate to capacity building, to educational needs for digital and precision agriculture, okay? And we've been actively trying to get people to talk about this and discuss this, and we still can't get engagement, okay? But it's clear that we need to teach into this space and we need to be more constructive. And that's my first big message. Very small font, but it's important to teach into this space. So in France, we've done this. So from 2017, we've tried to address this issue for digital agriculture, and digital viticulture is part of this, of course, through the construction of a virtual convergence laboratory. So this is called #Digitag, and it's you can look it up online if you wish to. And the idea of this is it just brings existing people, existing structures together and links them under this umbrella of digital agriculture. And these are people who are interested in digital agriculture from obviously the agronomy side of things, from the engineering technology side of things, computer sciences, electronics, physics, etc., but also from the economic side of digital agriculture, the legal, the social sciences side, how people accept these technologies. And the way this is done is there's about 10 million euros over 7 years to create master's projects, PhD projects, postdoctoral projects that build capacity within the people. And all these projects actually link multiple labs from different scientific areas. And that's the important thing. If I have a project, I have to link with somebody who's outside my area of expertise to have funding for my PhD program. And it connects people and it generates graduates who have a specialty in one particular area, like crop modeling, but who start to understand a lot more about the other aspects of digital agriculture. And so can develop ideas that are more holistic in nature. So that's the people side of the capacity building in France. The other side is infrastructure, and there's a few tools or few platforms developed. most recent one is called Oxytonome, but I'm not going to talk about that today. But that's really about Oxytonome is about agroecology, and it's very important, and about living labs and upscaling. But it sort of comes from this particular platform called the Mas Numérique, which is a digital farm that's owned by the Institut Agro in Montpelier, and is a platform for digital technologies. And it's quite a nice platform. It's a little bit different to a classical digital farm. Because it's just an open system where all of the industry, big companies, small companies, are invited to come and embed their services, their digital services, into the commercial operation of the farm. So it's about a 30-hectare farm just outside of Montpelier. But we have people who come in and generate soil information, canopy information, information within the winery, as well as the vineyards. And the advantage is they're all seeing what each other is doing. So it's not a competition. It's about trying to form connections and links between these different companies. And this is all available online. So you can see all the data that's generated. You can do a virtual visit. If you come to Montpelier, you can actually come and visit the vineyard and the winery and see all the data being collected and think about how it's being linked. And that allows us to teach in this very holistic way about how digital agriculture connects. The big advantage for me is it allows the enterprises to really innovate. So if I'm a company that generates information about vine size or canopy vigor, how does that feed into somebody who's delivering a service associated with differential spraying, variable rate spray applications? How does it link to somebody who's doing yield sensing and yield monitoring and modeling? These connections are really enhanced by having everything deployed in a very open way within a farm that's supported by the government and by education. And of course, it's a great place for the professionals to come in and see these technologies, either as an individual service or start to see how it's all connected and all creating value chain within the digital agricultural system. So, and what we're trying to push is that everything within that platform comes from a decision pool rather than a technology push. So we tend to be very good at this technology push where we identify a fantastic new technology and then we say, oh, we have this technology, how do I use it in viticulture? And what we're trying to do is flip that so that everybody thinks the decision I want to make is to be able to spray more effectively with less loss to the environment and higher coverage. What information do I need to do that? What technologies do I need to collect the information, to actuate, to actually apply the process, and then go and look for the technologies that fit that and build the system around the decision rather than around the technology. We're not always good at that, but we try to do it that way. And I want to give, in the last 5 minutes, a case study using remote sensing in France. So from 2006, and as I said, a lot of the work in viticulture is about remote sensing and canopy vigor. And for 15 years, we've had commercial services for growers to buy imagery in vineyards in France, okay, at all different levels, cooperatives, vineyards, within field levels. But 5 years ago, the industry came to us and said, you know, I'm a small, medium enterprise. I'm interested in value adding to remote sensing imagery, but what's the real adoption? How many people are using this? Who's using it? And we didn't have in France a way of actually surveying and knowing how well this technology, this widely acknowledged technology, was actually being used in vineyards. So we set up an observatory. We actually do these surveys quite regularly now to find out what's happening on the ground in France in real situations. So 15 years after the launch of the technology, only 1% of the total area under viticulture in France is commercially mapped. So the entire area is mapped by satellites multiple times a year, but only 1% of the area actually pays to have that information delivered to the vineyard and used for some sort of process on farm. And 85% of the information that's bought, that 1%, that 10,000 hectares, 85% of that information comes from satellites, 50% comes from airborne systems, and almost nothing from UAVs. So at the moment, we do lots of research into UAV systems, but there's no adoption. We do lots of research into bigger mapping, and there's almost no adoption. So we're losing something, we're missing something clearly here. So why was this low adoption? Are we delivering the wrong tools that are not relevant for management? Have we missed the target? Are we targeting growers when we should be targeting consultants? Is the diversity of application and needs actually a limitation or an opportunity? So we had a PhD student with a UAV company collect lots of information through a season, properly process that information, so we had temporal information. Then we actually sat down with the growers. We sat down with the advisors in a room, showed them individual images, time series of images, discussed it, asked them what do they see in the images, what information are they getting out, what information did they want to get out that they do not get out, what are the limitations, what are the opportunities? And they were enormous. There's lots of different things that they see, lots of different things that they want to extract, okay? So the question now becomes, how do we provide services that digitally enable the growers to extract this information so that they can be, or the growers or the consultants to extract this information to make it usable and simple to use. So we need to focus on advisors, not growers. And we need to focus on basic processes first, generic functions such as sampling, before we get to more complex delivery of services. Once they have a simple idea, they can have education to better understand what the image potential of the images is and build value-added services. But we've come in too far up the complexity chain for it to make sense for the growers and the advisors. So very simply, we went back and said the sampling issue is a great one to address. How do we better sample in vineyards? And we connected with constraint programming, computer scientists and agronomists. And we know that vineyards are spatially variable. So how do we optimize a route through a vineyard, knowing that we have to walk up and down rows, we can't walk across rows, and we know the statistics associated with the variability. So there's lots of fantastic mathematics. And every single vineyard would have a different way that you would sample that vineyard to get information, okay? So we have this wonderful tool, but how do you actually sell that to growers? And we're doing that by using an aggregate. So we give them an image, so they're now engaged with the imagery, and we ask them to select where would they sample. And the process tells them how long it would take to do those samples and what sort of error they would get. And they can play with this and try different numbers of samples, different places. And in the end, they can actually get the optimized route according to the algorithm. So it's a game that engages them, shows them the value of the imagery in terms of sampling, which is a concrete application in vineyards. And we can, using this at the MAS numeric, we can do this with the general public, with industry people, with researchers, with students. So they're learning and they're feeding and they're engaging. Okay, so last slide. Lots of new technologies. So certainly think about how we can develop these, but think even harder about how to translate these and what's needed for that translation. We're in a multi and interdisciplinary area, and we need social sciences. We need to understand how the industry accepts and sells things and buys things. And ultimately, it has to be about the decision, because that determines adoption. And that's 15 minutes. So thank you very much.
Thank you very much, James. What an inspiring talk. Well, I would like to invite you to come to Portugal as soon as possible, because I take the opportunity to say that we at Ciência Viva, we are building a network of Ciência Viva farms throughout the country. And we are looking to the precision agriculture is very needed. And is very good to know that more and more we will have super cool sensors and robots in agriculture. This is good to attract the youngsters. And by the way, in the slides, it's very good to choose cooler pictures of agricultures to attract the youngsters to the field. is needed. This. Well, thank you. Teresa Pinto Correia from University of Évora. Yes, you can go to your presentation. Thank you so much.
Okay, thank you very much. I don't know how I change my slides. Someone will change. Yeah. Okay, good morning, everybody. Thanks very much for the invitation. I would like to say hello to the Ministry of Science, to the President of FCT, the President of Ciência Viva, and all my colleagues in the presentation and all the participants here and online. So I'm coming from the University of Évora and representing this new associated lab, Change, which is dealing with global change and sustainability issues. And mainly, I think I would like just to raise this question, why we need an ecological transition. It's really, we need to change, and we need to change because we have urgent issues to deal with at global level and in each of our countries. We have these climatic and environmental pressures which connect to demography and socioeconomic instability. And that means particularly that some people will be really in very difficult conditions in the very near future. They are already, they will be much more in the future. But mainly what I would like to highlight here is in order to solve these issues, we need to understand this constant interaction between nature, people, and economy. And I'm very thankful to the previous speaker because he was addressing so much this question of understanding people. And that's pretty much what I would like to also to raise, the importance of understanding people's behavior in order to start the change we need. We address these issues in this new associated lab, but in particular, I would like today to raise the question of the soils. Soils are really the backbone of our ecosystems, and we have a huge problem with our soils today. I have the privilege to be part of the mission board on soil health and food for Horizon Europe. We have now been working for 2 years in the soil mission, and we have been asked to raise a very realistic but also ambitious goal. And we started by saying, well, we need to act now so that we have 75% of our soils healthy in 10 years. And that's pretty ambitious, that's almost impossible. So after discussion with the member states and with specialists from a broader assembly from the different countries, we got to a maybe more realistic goal, which is to have 75% of our soils healthy or on the way to be healthy, according to indicators which have been agreed on beforehand and the thresholds which are related to each context. But in any way, it's very ambitious, but we need to start. And why do we need to start? We need to start because soils are extremely important to deliver the different ecosystem service we depend on, not just food and fiber, but everything. And we have heard today also from the Secretary of State opening this session that we need to look at all the elements of the value chain. And the first element is natural resources. And this natural resource, particularly soil, is a forgotten one. We know a lot about water. We hear a lot about water, about climate, about biodiversity. We hear not enough about soil. But soils are scarce, and they take hundreds of years to generate, but they take very short to degrade. And they are threatened. We have almost 70% of soils in Europe. They are unhealthy, and this has to do mainly with management practices. And soils are very important because they are the backbone of our ecosystems for the Green Deal, to attain the objectives of the Green Deal. So, and why it's urgent to act? Because all the scenarios in Europe show an increased vulnerability of soils, and that climate change will affect even more this issue, not only by degrading more the soils, but by creating a climate where production will not be possible in some contexts, or areas which will be flooded where the most fertile soils are. And a loss of carbon from a small part of our soils correspond to a lot if we think about extra cars or other ways which are releasing carbon to the atmosphere. While on the other side, healthy soils are really carbon storehouses, and they could be really strong contributors to the objectives we have with the Green Deal. So soils are really extremely important, and we need to think more about them for this ecological transition. In the EU alone, and Portugal is not one of the best countries in considering these, we have 2.8 million sites contaminated. We have a lot of agricultural soils which have high levels of eutrophication. We have cropland soils losing carbon. And especially I think for us, which is what is very important, is this land with very high risk of desertification. This is particularly in Southern Europe, but it's going on all over Europe. And calculations, all these numbers, they come from the mission, from our mission, and the figures were all provided by the Joint Research Center and by different also worldwide data sources. So we are losing a lot of funds, really a huge amount of money by everything we have to do to compensate by the degradation of soils. And what is the cause? The cause is management, mainly, and unsustainable business models which are driven by market, but also driven by policies which are non-adequate to support soil regeneration. So, what has been the discussions on the mission, where have they driven us to? And this is particularly for me, and I think for the previous speaker also, is that it's people and their actions they need to change. Soils do not change alone, so we need to change behavior if we want to change soils. And we need to change behavior if you want to apply more precision farming on vineyards or on everything else. We need to look at people. And we need to look at soils as being part of a system. So they are not just soils we need to look at, but we need to look at the farming systems, the forestry, the landscape level, the national policies, the global market change. So we need to look at everything as a system. And for acting for soil regeneration, we also need a systems approach. And also because when we regenerate soils, we are not only improving the crop or improving the pasture, but we are improving the trees, we are improving biodiversity, we are improving carbon storage. So the action we do on soils will affect all the objectives of the Green Deal and will affect many other objectives we have on the future sustainability of our systems. I wanted to show this to show you how this role of people is very important. This is an image taken in 2018 of a property in the middle of other properties. It is a property with agro-silvopastoral systems in Alentejo. And this one, which is green, it has been followed by one of my colleagues, specialist on soils, Mário de Carvalho, and a landowner who has been working with him for 20 years. And in this property, they have been investing in correcting soil toxicity and improving soil fertilization. They have cattle production, they have trees, and they have grass and feed for the animals enough in the farm. You can see the green shows the regeneration of the biomass, so the pastures grows in April, while all the year around you have the same system, but no improving of the soil. And this image, I think, tells for a lot of other text. It shows very well that if you invest in soils, you have a result which, of course, will have an impact in your business sustainability because you are producing much more biomass on your own farm. You don't need to buy so much. And this farm has been lucky enough to work with his colleagues, so have the introduction or integration of science and knowledge in his farm management. But why do the others around not use this knowledge? They know the farmer, they know the researcher, they could also change their system, but they don't do it. They don't do it because they are locked in a past dependency or of a certain behavior. They have always done like that. Their father has always done like that. Their association tells them to do this. They don't need to change because they have a subsidy which gives them some level of income. This farmer in the green property, he does need subsidies. He receives the subsidies, but the subsidies are extra income. His own production linking to the market gives him enough to pay for his expenses. So the subsidies are an extra, while all the others are subsidy depending for the survival of the farm. So my argument here is that we need to understand, which is also the argument of the mission board. We need to understand soils, but we need much more, or at this level now, we need also to understand people. So it's not only about translational science, it's also about understanding behavior, understanding business models. So it's translational science, but much more than that. It's really about the role of social sciences in getting the change we need. So the mission goal, and this slide is pretty heavy, but what I wanted to show you is that this is the structure of which has been shown now to the implementation plan of the mission, which is right now, this week, under evaluation. The mission has defined these 8 objectives with specific targets, which I will not talk about. I want to talk about the operational objectives, because we have a research and innovation program, which hopefully will be financed. But we also have these living labs and lighthouses, which are a key element of the mission. We need to do research close to those who are going to use it. So we need to do research in real-world farms, close to people, to foster the change in behavior. And then we need monitoring, and we need more soil literacy. So we need to have people to understand the role and the importance of soils, people around in society, so that they press farmers, but also policymakers, to give more attention to soils. So the role of science, and that's what I would like to address, the role of science has to change in order that we progress to this transition. We need more integration. We have a lot of knowledge on soils. A lot of publications have been ongoing on soil science and on soil, different integrations in the soil, but we need more integrated knowledge on soil health and the drivers affecting soil health. We need to have research which is contextualized. That means tailored to each specific context. So the living labs are a fundamental work, and we will have them, hopefully, but we will have them financed by the European Horizon Europe, but we will also need and can have others which will be financed through different ways. We need much more of this research on the regional circumstances. We need system thinking, that I've talked already about, but then especially we need more equity between natural and social sciences, and to take this seriously. It's not just about integrating some data on the farmer's age or the farmer's education, which is real social sciences. Social science is about business models, it's about markets, it's about behavior, about collective action, it's about all these. And we need these at multiple scales, from the field to the regional and national level. Of course, we need an enabling environment, adequate policies and adequate market mechanisms, but research can play a very important role. So there is room for change. We are addressing it in our lab. We have to think, and this is very much connected to the previous speaker, innovation is not only technological, it's also organizational and social. Innovation is not only on the farm, but across the value chain, so behavior of consumers also need to change. Innovation is also strongly needed in research and innovation. We need new approaches and goals. We need to really talk more together so that we see how we integrate these social sciences, so that we can tackle the sustainability challenges together. Thank you very much.
Thank you very much, Teresa, just on time. Thank you. And we know that the most difficult thing is to change behavior, isn't it? And so more engagement with citizens is always needed. And we need, I take this opportunity to say to Teresa again, I know you are in tone with us at Ciência Viva, to have a Ciência Viva farm in Alentejo. Well, and especially we need to be attentive to the new generation that are very committed to respect the low carbon products. We know that they are. So thank you very much. Now it's time to invite Gabriel Marais, please. Thank you.
I think I can remove my mask. I'm COVID negative, I was tested this morning. Antes de mais, eu queria dizer algumas palavras em português para agradecer os organizadores, especialmente o Vincent Brignol e a Paula Alves, para o convite e a oportunidade de apresentar a minha investigação e o projeto BIOPOLIS. So I'm going to continue in English, so that as many people as possible can follow my presentation, including the online participant. So today I'm going to talk about French-Portuguese cooperation. So I'm not yet at CBO. I'm still a CNRS senior scientist at the University of Lyon in France. I'm going to join CBO BIOPOLIS from September 2021. So I'm coming from one of the largest departments of ecology and evolution in France, and I'm leading a team there, mainly working on the evolution of plant sexual systems, mainly using approaches such as genomics and bioinformatics. So you probably know that most of the animal species have males and females. And you probably also know that in plants, it's the opposite. Most species are hermaphroditic. Only 5% of the species have males and females. They are called dioecious species. They nevertheless represent about 15,000 species. In animals, we roughly know the sex determination mechanisms in more than 90% of the species. In plants, those mechanisms are known for a minority of species, only 3%. In animals, in many species, the majority of the species, sex is determined by sex chromosomes. In plants, in some species, we know that there are sex chromosomes in species with males and females that are also called dioecious species. But we have very little data on plant sex determination and plant sex chromosomes. But it's an important topic at the fundamental basic science level, because we would like to understand how sex is determined in plants, and also at a more applied research level, because the dioecious plants, they are overrepresented among crops. 17% of the crops, they are dioecious, or they derive from a dioecious progenitor. And of course, understanding sex determination in these crops is critical for controlling their reproduction. So in our group, we have developed bioinformatic tools to study sex chromosomes. Sex chromosomes, they are the hardest chromosomes to study in genomics. If you know about genomics, you know that. And in our group, we have developed specific tools to study them. I'm not going to explain those tools today to you, but the idea of those tools is very simple. you just need to sequence a couple of male and female individuals, and using our tools, you know whether there are sex chromosomes in the species or not, and you can get the sequence of the genes on the sex chromosome. So these tools, they are really powerful, they are quite cheap, they are very efficient, and they work on all the possible, all the organisms you can think of, plants, animals. In the group, we have applied those tools on plants, mainly on dioecious plants. And here I'm going to give this example of, this is a study that we did on grapevine. So in grapevine, the wild progenitor, Vitis sylvestris, is dioecious. There are males and females. And sex is determined by XY system, just like in humans. Females are XX and males are XY. And Vitis vinifera, cultivated grapevine, is hermaphroditic. And we know that this is because the Y chromosome has been modified. And using our tools, we were able to identify the sex-determining genes in Vitis sylvestris, and also the genes that was modified in Vitis vinifera. And so we published this work last year, and well, it was discussed in several French newspapers. We also applied our tools to Cannabis sativa and Humulus lupulus, cannabis and hop, two plants that come from the same family, Cannabaceae. These crops, they are still dioecious. They have males and females. Sex is determined in these plants by a XY system. And in these plants, only the females are of economic values. Okay? So there is really a big challenge to have only females crops. We are talking about billion-dollar industries, both cannabis and hop, but with very few biotech tools. And using our tools, we were able to identify the genes on the sex chromosomes in this plant. And we are now developing genetic markers in Cannabis sativa to be able to sex the plants very early and to select only the females. Okay, so in this slide, the colleague who is next to me, Raquel Tavares, is actually my partner, and she is also a lecturer at the University of Lyon 1. And together, we have been spending some time at the Instituto Superior de Agronomía, that you can see behind, these last 2 years as visiting scientists. And the idea of us staying here is actually to develop a new collaboration on grapevine. I wanted to continue my work on sex determination in grapevine, and I started a new collaboration with Margarita Rochetta, who is a scientist at ESA and who lead a team on this particular topic whose work is internationally renowned. And Raquel is developing a project on viticulture and global warming. A very interesting project. The idea is to identify some genetic variants in grapevines, in Portuguese grapevines, that allow heat and drought resistance. and she's collaborating with the group of Elsa Gonçalves and Professor Antero Martins at ISA. And also we have involved some people from INRAE, from Colmar and Montpelier. Okay, so now I will switch to the BIOPOLIS project. So as I said, I will be joining the BIOPOLIS project in September as Director for Research and Innovation. So BIOPOLIS is actually a H2020 teaming project. So the idea of the teaming project is to associate an institution from a more advanced, more economically advanced country for a less economically advanced, with an institution from a less economically advanced one, which is still the case of Region North of Portugal. And the idea is to help capacity building of the institution, the later institution. So BIOPOLIS is going to run from 2020 to 2030. It's a project in the field of ecology, and there are three main partners: CBO, Porto Business School, and University of Montpellier. And there are 15 million euros from EU, matching funds of the same amount from Region North, other funds of about 100 million euros for a total of 130 million euros. So it's a quite big project. So let me focus on two of the partners, CBO and University of Montpellier. So CBO is a research center on ecology and evolution, headed by Nuno Ferrand, who is here today. And it's located on the Veyron campus near Porto. It has about 500 people, and it is already making excellent research. For example, I put here a cover of the Science magazine by some results from one of the CBO group on the sexual dichromatism in birds. The other partner, University of Montpellier, whose coordinator for BIOPOLIS is Pierre Bourseau. He's an excellent institution. Actually, he's in the top 3 of the Shanghai ranking from ecology since 2017, and in 2018 and 2019 it was first actually. It was the first time it happened to a French university at that time. There are 11 departments in ecology and evolution involved in the BIOPOLIS project, the main department actually in ecology and evolution in Montpellier. So the idea of the BIOPOLIS project is really to try to make a connection between research and research tools developed in ecology with big societal challenges such as global warming, biodiversity loss, green cities, and so on. And there are 3 lines of research. The first one is about understanding biodiversity and monitoring biodiversity and developing new tools to monitor biodiversity. The second line is about understanding ecosystem and maintaining ecosystem services and restoring ecosystem services. And the third line of research is about biodiversity. And it's directly connected to the topic of the symposium. So I'm going to spend a little bit more time on this one. And the idea of this line of research is to first to study all the biodiversity that is important for agriculture in Portugal. The context is, of course, global warming, and so there is a focus on the animal, microorganism and plant that are already adapted to heat and drought. And the idea is to use genomics to actually characterize biodiversity, to help understand it, to protect it, and also improve it. And the final goal is, of course, to provide solutions for developing a sustainable and resilient agriculture. So this is the BIOPOLIS work plan. It's quite complex. I'm not going to go through it, but here I just wanted to emphasize a few strong points that I noticed. So the first one is attracting talented researchers, actually attracting and keeping talented researchers. And here the idea is to provide good and long-term contracts to the researchers at CBO. Also, the idea is to create a positive institution. So this is very important, actually. Quality of life is a very important topic in all professional areas, including academia. And also, I think I can help on this task because I'm trained actually on this topic. There is also the idea of creating a campus, and this is very interesting, with merging research labs, companies, and NGOs to accelerate the transfer of knowledge from research to society. There is also... Okay, I'm already there. There is also this idea of communicating to the public and also developing an international strategy. So, of course, there is this dimension of France-Portugal cooperation, but there is also this idea of working with African countries using the network of both CBO and Montpelier. And I think it's very important because the environmental issues, they are global, so they need global response. Thank you.
Thank you very much, Gabriel. Well, sure, we will have some time for questions or small comments. We are in the last 30 minutes in our session, and we would like to have questions to our speakers, and especially also to this last one. I'm seeing now in the room Ferreira, which is the big responsible of this BIOPOLIS project. So maybe you have some comments, I don't know. But all of we can make some questions or small comments. Now, Carlos Faro from Biocant. Can I say now that we are already in conversations to have a new science center there in the region, Cantanhede. I'll take the opportunity to talk about the network of Ciência Viva Science Centers and the farms, of course. Thank you, Carlos.
Okay. Good morning. So, first I would like to thank the organizers of the event and of this session for their kind invitation and the opportunity to talk about this project that is only possible because of the investment that we made on science over the past 40 years. And it, in my opinion, is a very good example of how we are translating science into economic development and social well-being. And this project, the name, of course, it's a company, the name is Carbocode, and the address and is a very let's say, broad project, but the application I would like to talk today is about the food one, and particularly the one in the food supplement market. So this is a huge market. It's a 120 billion market with really growing a lot every year. And even during this COVID context, this market is even more robust. And this is something that is, of course, a unique opportunity. But this is a kind of unregulated sector. And this is not as well as, for instance, the pharma sector, but there is room for improvement, and I think that there is really a good opportunity to bring new projects into this market. So, of course, there is considerable pressure to increase this regulation in the sector, and also the legislation is expected to make it mandatory for more stringent safety tests, quality control. So this has to be really a challenge for the coming years. And there are, of course, also a high demand for control products, namely in their impurity profile. And this is why food supplements like the plant extracts are under big pressure nowadays. So we have to move forward and develop new processes to produce these essential components. And really, the biotechnology is in the forefront of this new development, and especially the use of bioprocesses. And by bioprocesses, I mean fermentation, biocatalysis, and so on. Because this is really a way to produce these components in a very sustainable way, but also in a very, from the economic and environmental standpoint, in a very efficient and sustainable way. So this biotechnology is really important to target this challenge, and especially the recent advances in the areas of molecular biology, synthetic and systems biology, bioinformatics, genomics, and so on. So we have nowadays a huge array of technologies that allowed us to produce almost any natural compound that is originally found in plants or in animals. And these compounds can be produced in microorganisms, usually in bacteria or yeast. And also these microorganisms can also be a source of new additional molecules without the need for genetic modification. And of course, molecules that we know have a potential or a health benefit. So this is really a new scenario in the food industry. And For instance, I would like just to comment on this new milk that is animal-free, is produced in a yeast, actually. But this milk, for instance, this milk is not exactly the milk we have from the natural source. So probably the proteins and the minerals are much like the same, but there are small molecules that are functionally important that are not present in these new foods. And this is really a new opportunity, is to produce these other compounds as ingredients for the food industry so that these new products can be more likely the natural ones. And so this will be a challenge for the next coming years. And we at the Carbon Code, we are really trying and managed to develop technology to produce human-like sphingolipids. And why are sphingolipids important? Because sphingolipids are really crucial molecules for the overall human health. They are present in different parts of our body. And the main source of these molecules is the milk, and especially mother's milk. Breast milk is really the best source of human sphingolipids. But as you can understand, it's very difficult to develop an industrial program to produce these human molecules from mother's milk. So there is a need to develop new technology so that we can produce these molecules at large scales using biotechnology. And indeed, this is what Carbon Code made over the past 3 years. So we developed a significant portfolio of technologies that allowed us to produce for the first time these molecules. And we are now really in the process of going through all the regulatory pathways that are required in order to get these products into the market. And the idea is really to create a new industry in Portugal based on this science. And really, that's what we are trying to achieve at the moment in Biocant. So Cantanhede will be the place where all the industrial development is going to take place. And the first application of these molecules, these ingredients, is really for the infant formulas that nowadays the food industry wants to bring these infant formulas closer to the breast milk. But they are missing essential components such as these glycolipids. And now they are made available by Carbon Code, and really they can be added to the next generation of infant formulas. And the company is already working with Nestlé, Albert, all these big companies who are really interested in getting these products and take it to the world market. But of course, this is a huge portfolio of molecules. The first stage, we are taking just 2 molecules into the market, but many others are now in the pipeline and will be produced and introduced as follow-ups in the coming years. But these molecules can be used not only to feed infants, but also they can be used for adult nutrition markets. And it's very interesting in the sense that we lost 60% of our gangliosides when we get 60 years old. So there is a need to replace these components, and we can replace them in the diet because they fulfill important roles, not only in the brain plasticity, but also in preventing age-related cognitive decline. So the goal here is really to have this company ready to export by 2024. And the company is kind of model of we are looking for this new Portugal. Is really a company that is based in high quality advanced technology with a very strong IP portfolio. The company already submit or filed 50 patents, 25 are on the pipeline, and we have more 40 planned for the coming 2 years. So this is something that is going to give us a huge competitive advantage in the future. And of course, we want to manufacture this in Portugal, contributing to the exports of this country. And we set a very clear goal. By the end of this year, we have to export more than the Porto wine all together. And in the project that is only based on science. And this is just the picture of the campus that is now in the process of being licensed, and I hope to get it done by 2023. So thank you very much.
Thank you, Carlos. So I will invite you to take the floor for questions or comments. We have 10 minutes, 12 to do this, and take this opportunity to ask questions to our speakers. Yeah? Wait for them.
Thank you all.
And James is there, as you see. Hi, James.
So thank you all for your contributions. I think the panel was very diverse, and we learned a lot from the different areas. I have a question for Carlos, because I think this is a multidisciplinary approach that you have here. And I'm wondering about when you are going to put one product like this into the market, and of course we are talking about global market, and you mentioned the relations you already have with big companies, but I'm wondering how you can also enroll, for instance, the hospitals, and if you have also to go for trials before you go with these products to the market. Do you do the clinical trials in Portugal? Were you able to enroll our clinicians in this type of new products that we want? Because I think if we want to move here, this connection is also very important.
Well, thank you for the question. I think that for the initial studies, we can do it in Portugal. Actually, this is the project that we are going to submit to the PRR. So the idea is to set really a consortium that we can develop these products. But when it comes to the regulatory approval, we have to acknowledge that in Portugal we don't have experience yet and recognition. So for that particular type, and at that stage, we are going to work with international companies that are already recognized by the industry. For instance, Nestlé, they work with only 1 or 2 CROs, and they really want the efficacy studies to be done with them. But during the research and development stage, we can, of course, do it in Portugal, and this is our goal.
Thank you.
I know Teresa would like to make an intervention.
Yes. Yes, I have a question to you, James. Are you listening? Yeah. Okay. Because you were
Robert, yes, Isabel.
Okay. You were mentioning the decision pool, which is as important as the technology push. And what I was wondering is what if you are working in your unit with other scientists, social scientists, for increasing this decision pool, how do you do this? Or are you raise the problem, you would like others to tackle it, or is it something you are tackling directly, coming from your background in precision farming?
Yes. Well, I think it's a very big problem. So it's not something we can do alone. We do do this within our research group. So the research group is called Decision and Modelling. So we work a lot on multi-criteria decision making in a spatial context using agri-data sets. And that's done with mainly with computer scientists who are particularly interested in fuzzy systems and understanding that decisions in agriculture are always an offset between what the farmer wants to do, what they can do, and from their economic point of view, but also from the services and the support that they have to make decisions. So these are always very complex decisions. So it's not a one-size-fits-all, and we need very flexible decision systems, and we don't really have them. In precision agriculture, we have some technologies that are really well adapted because the decision process is very easy. And the really classical one of that is auto-steer tractors. So the tractor has the GPS, the very high-quality GNSS steering systems, and they drive in a straight line with no overlap, exactly where you want them to go. The decision is made by the system, and it's a very good decision and a very simple decision, and the uptake is enormous. You know, these are no longer, in my opinion, precision agriculture. Auto-steer tractors is just agriculture. Okay, so it's just mainstream agriculture nowadays. But you have other things like the remote sensing technologies that don't get taken up because people are not quite sure what decision to make and what decision is best for their production system, and we have to fill that gap. And it's a collective effort between computer scientists, between social scientists, and between agronomists. And the process must start by talking to the end users, whether they're advisors or whether they're producers, at the start of the process. So you co-design a service, a system, knowing where the decision is going to be made at the end. And we try to do that as much as possible, but it's actually the big limitation that we have in France and with this Digitag project is the access to social sciences to help us to do that. So I think the demand for social sciences in agriculture in the next 5 or 10 years is going to be a limitation to how we transition to agroecology. Because the example that I gave was very much people who are conventional viticulturists looking to use a technology. So they're actually quite invested in the idea that technology can help us. In some cases, I think when you move to agroecology, organic farming, you're going to have more of a social barrier there because a lot of people are a little bit hesitant or a little bit more wary of technology, of these disruptive inputs coming into their system because they want a natural system. But my opinion, and other people have different opinions, is that the digital revolution is going to be critical even for agroecology, not just for conventional modern agriculture.
Okay, thank you. We have to ask for interventions. One is from Minister Manuel Heitor, other is from Ana Noronha. There is one more because the room is closed for questions. Be precise and short, like we want the agriculture is. Thank you.
Thank you very much. And let me thank you for the brilliant session and the presentations, which are very much within the topic of our event, Science That Changes Tomorrow and Transforms the Economy. I have 3 very brief questions. All of you have addressed consumers and citizens at general. And in this context, actually, some of you addressed very well the education issue. But let me bring these 3 questions. First is the regulatory context. When we look at the last 30 years, we know that Europe at large has been quite conservative on adopting new, namely science-driven or genetically modified foods. And we know why, because of the economic pressure of many monopolies at the European context, which have not allowed that. Actually, last year in our Science 2020, we have here a Nobel laureate presenting the Nobel Declaration against the way the regulatory framework for agribusiness in Europe has been developed. So my question is, have we the correct regulatory framework in Europe to adopt many of the solutions that you have adopted, or we need, or you depend on a new regulatory framework? The second is, from the first presentation to the last one, how far to educate consumers in general to adopt these new products? And actually, the context of Rosalia being the chairwoman and chairwoman of this session is very important. How can we promote scientific culture to the population to really foster this type of evolution? My third question is about education. My understanding is that today was clear that we have here the convergence of different areas. I believe in the scientific, biological, and ecological area. Actually, universities at large attract very good students, but on the other hand, in the more traditional agro-business sector, we know that there has been a big problem in attracting talent for agro-business schools. And the divide is enormous between scientific-driven, say, science and biological, bioscience education, and the pattern of agro-business education, more professional type of schools, which are really, really a big problem, not only in Portugal, but throughout Europe. And reforming that education has become a great issue throughout Europe. They are quite conservative, quite close, and they are not changing. So actually at the European level, this has been discussed. How can we foster the change of the agro-related and agro-industrial schools throughout Europe to adopt this new scientific approach? Thank you.
Thank you. Who would like to start? The questions are addressed to you all.
Okay, I can start. So regarding the regulatory issue, I think now that what we need is a stable framework. It's very difficult to work and plan when the regulatory framework is changing over the years. So it's very important to keep it stable. And once it is defined, we want to get it in place for several years so that the companies can plan according to that framework. And because these projects, nutrition is not like pharma. So pharma is more demanding, it's a long process, and this is the advantage of the nutrition area, is that the regulatory is shorter, the demands are less than in the pharma space, and then we can get the products into the market in a faster way, okay? But the key principle is that we need stable regulation, and we really need to plan, and stability is very important in this. Regarding the talent, I believe that in my case, the project is slightly different from the others because this is pushed from the technology side, so science and technology. And in Portugal at the moment, we are very well. We still have some talent. We still have a pool of talent. I don't know for how long, but this is a big advantage that we had in the past, and this is an advantage to attract projects from abroad. I think that we still need to take care of this. So the talent is really a key issue, And I think that we should now start to design a more aggressive policies to bring people, Portuguese, who are abroad and want to come back, because they can bring new competences, new networks, and this is something that we really need to do. But regarding the talent to support development, for instance, like Carbo Code, I don't see a problem in Portugal at the moment.
Yes, I will be very short. Thank you very much for the questions. I don't know about the regulatory framework, if I'm replying to your question, which type of regulatory framework you are mentioning, but I think really we are very much in need of a regulatory framework at European level and national level for preservation of our natural resources. So a regulatory framework which says you can do this, but you cannot go as far as degrading the soil in this way, or creating a structure which totally makes impossible for biodiversity to regenerate, or water quality. So I think this we need. We have a little bit on water, but it's lagging behind. We need much more preserving these natural resources and guaranteeing these by legislation. Then about the education, that's the one I'm going to reply. I think we can change if we invest much more on pilot education and not trying to change the whole system. If we try to create an education driven by project learning, like we have the examples in Scandinavia, in Denmark, which I know very well, but if we try to create a system of education in agronomy where we work on project teaching, then they will need to integrate the different sciences. But it's very difficult to change a whole system of education, so we should invest in pilots educations and see what they can. And that would be really great if we can do that in Portugal. Thank you.
Gabriel, would you like 1 minute, please?
Yes, I don't know if you can hear me. Yes. Yes. Okay. So I'm a newcomer to the BIOPOLIS project, and I'm still in the phase of discovery of the project, the CBio, and also the Portuguese agriculture. So when you mentioned the regulatory issue, it rang a bell. I remember from what I read that the agrobiodiversity that I mentioned in my talk, for example, in grapevine, I mean, the Portuguese biodiversity is amazing. There are 500 cultivars in Portugal. It's the same number as in France, but the country is 5 times smaller. And it's also true for other important cultivated species. And apparently, this biodiversity is not really protected. So there are labels that many species do not have, some labels that protect them, and it would be important. About cooperation with different Portugal and other countries, I think BIOPOLIS is an example that it can happen. We hope to really stimulate a lot of collaborative projects between CBio and Montpelier. And I know that there is this idea of trying to get other EU grants accepted in the course of the BIOPOLIS project. And also, about the point on education, I think it's a very important issue. It's also in the BIOPOLIS project. They have different actions for public outreach, and in France, I know that French are aware of the big questions about agriculture. They are very opinionated about what kind of agriculture we should have in the future. I don't know about Portugal, how it is in Portugal, but if it's not the case, I think we should stimulate it. We should help stimulate it, because I think the citizens, they should express what they want for their agriculture, for the future agriculture.
Okay, thank you, James. Have you 1 minute comment, or?
Well, I won't comment on the situation in Portugal because I don't really know it there. The policy and at a European level, how technology, so from my perspective, how digital technologies are regulated is critical. The classical example is how can you use a drone, a UAV, in vineyards? You know, there are regulations about how far it can fly from you, how long it can fly, how high it can fly, and these sorts of things. And they set the groundwork for what you can do with the technologies. So that's critical that those policies and those regulations are set and are fixed, because all the services will feed off those. The education is, yeah, as I said in my talk, it's understanding, not understanding, developing the next generation of people who will work in this area. They have to have a real interdisciplinarity in their education. That's not to say that they're an expert in multiple areas, but that they are abroad and across different problems and different ideas that come in from economic, social, technology aspects of future agriculture, so that they can go and they can talk to the right people and they can learn and they can bring that knowledge back into their particular area of expertise. And it's really hard to find people who can talk to both computer scientists and growers and social scientists and make sense to all three of them and integrate the knowledge from all three of them. But we need those sort of people in the future.
Thank you. Anna, I hope you have only a comment, not a question.
I think that all the relevant questions have been done by now.
So, we finish. Thank you so much. Don't forget to be in touch with all of you, but also with Vitor Espírito Santo. He specifically said that he's available by email or social networks to make questions or comments. Thank you very much.
Para encerrar a sessão, passamos uma mensagem em vídeo da Ministra da Agricultura, Maria do Céu Antunes.
A pandemia da Covid-19, com todas as limitações e efeitos que trouxe à nossa vida em sociedade, evidenciou e acelerou algumas transformações que já estavam em curso, nomeadamente a transição digital. Não só trouxe uma mudança brusca, como mostrou a importância central que o setor da agricultura, da ciência e da inovação tem na sociedade, no nosso dia-a-dia e bem-estar de todas e de todos. E agora que estamos num prudente caminho de regresso à normalidade, na fase de recuperação, é mais evidente a necessidade de construirmos sistemas alimentares mais sustentáveis, resilientes e justos. Ganhamos uma maior consciência coletiva sobre a importância do conceito de uma só saúde e temos de nos empenhar mais na conservação e na recuperação da natureza. São grandes os desafios globais que enfrentamos relacionados com a agricultura, mas com a alimentação. Destaco a necessidade de fornecer uma alimentação segura, nutricionalmente equilibrada e de forma estável a uma população mundial em crescimento e com alterações no padrão de consumo. Temos de combater a fome e a malnutrição existente no mundo, que se agravou com a pandemia. Temos de combater o flagelo da obesidade e do excesso de peso, sobretudo nos jovens e nas crianças. A par, temos uma pressão crescente sobre os recursos naturais e sobre a urgência climática. A agricultura é das atividades humanas mais afetadas com as alterações climáticas e a bacia do Mediterrâneo é das zonas do globo que vão sofrer maiores impactos. Aliás, os efeitos e esses impactos já estão aí com o aumento da frequência e da severidade de fenómenos extremos como as secas e o granizo. E é por isso nossa responsabilidade coletiva fazer tudo para cumprir os objetivos de desenvolvimento sustentável. Pretendemos valorizar o Pacto Ecológico Europeu para impulsionar a utilização eficiente dos recursos através da transição para uma economia limpa e circular, assim como restaurar a biodiversidade e reduzir a poluição. E a agricultura tem um papel fundamental, conforme está bem expresso nas estratégias do Prado ao Prato e da biodiversidade da União Europeia para 2030. Foi e é uma atividade fundamental na retoma do crescimento da economia e na valorização do território, conforme podemos comprovar nos últimos meses. Mas para além destes desafios, existem oportunidades para a construção de uma transição agrícola digital mais sustentável, mais justa e mais inclusiva. A nova política agrícola comum, que vai entrar em vigor em janeiro de 2023, vai ser parte fundamental desta mudança através da promoção de uma agricultura mais ecológica, mais resiliente, que contribua para o desenvolvimento das zonas rurais e para o reforço do sistema agroalimentar europeu. É crucial, por isso, o uso mais eficiente dos recursos naturais, garantindo a integridade dos ecossistemas. E, por isso, temos que apostar mais na ciência e no conhecimento. A produção de partilha de conhecimento são essenciais para incrementarmos a inovação e a sua difusão, de forma a respondermos de forma mais eficaz aos grandes desafios. Sabemos que a investigação científica e a inovação são alicerces da construção de sistemas alimentares mais sustentáveis, equilibrados e inclusivos, assim como um ambiente mais saudável para termos mais futuro. Por isso, uma das principais apostas deste Ministério, o Ministério da Agricultura, é a Agenda de Inovação 2030, a Terra Futura, que tem como propósito fazer crescer a agricultura, inovando-a para podermos entregar à próxima geração. O roteiro para a próxima década, construído em linha com os Objetivos de Desenvolvimento Sustentável, bem como com as estratégias do Prado ao Prato e do Pacto Ecológico Europeu. A agenda foi produzida por quem está no terreno e com quem está no terreno. Promovemos sessões em todo o país. Ouvimos os agricultores, os empresários, os investigadores, os autarcas, todos os atores do território. Estamos a agilizar e a criar condições para que a inovação seja sinónimo de mais rendimento, de mais saúde, de mais inclusão e de mais futuro. E como é que o queremos fazer? Defendendo uma sociedade mais consciente da sua alimentação, das suas escolhas e do seu bem-estar, protegendo o planeta, valorizando os recursos naturais, apostando numa cadeia de valor inovadora e competitiva e contando com um Estado que promova o seu desenvolvimento. Sabemos, pelas comparações internacionais, que temos de melhorar o nosso ecossistema de inovação agrícola, tornando-o mais robusto e menos fragmentado. E para isso o Ministério da Agricultura vai dinamizar uma rede de inovação em todo o país que ajude a responder aos principais problemas e desafios do setor agrícola e alimentar de forma mais coerente, robusta e focada, mobilizando todos os nossos recursos, incrementando as parcerias com as várias instituições do sistema científico e tecnológico nacional. A importância desta agenda levou a que fosse incluída no Plano de Recuperação e Resiliência, aprovado há poucos dias pela Comissão Europeia. Vai ser financiado com 93 milhões de euros, aplicados na sua execução ao serviço de um futuro melhor para todas e para todos. Vamos implementar projetos através de parcerias que respondam às principais necessidades identificadas no diagnóstico do Plano Estratégico da PAC, que se enquadrem nas iniciativas emblemáticas da Agenda Terra Futura e cujos resultados sejam escaláveis e transferíveis para a atividade económica. E estamos a apoiar o setor nesta transição. Ninguém vai ficar para trás. Recorremos ao financiamento do pacote Next Generation para o Programa de Desenvolvimento Rural. E por isso temos já anunciado um conjunto de apoios que querem garantir uma agricultura mais preparada, mais resiliente e que os valores de produção sejam compatibilizados com os valores ambientais. Como disse, esta pandemia trouxe desafios, mas também oportunidades. E precisamos de construir cadeias alimentares que sejam um benefício para todos, agricultores, consumidores, para o ambiente e clima, para a nossa economia e para a sociedade em geral. A agricultura, aliada ao melhor conhecimento científico, é e vai continuar a ser certamente um fator decisivo e parte da solução para os desafios que nos aguardam. e por isso agradeço esta participação.
Damos assim por encerrada esta sessão e chamamos a maior atenção para o início de todas as sessões paralelas dentro de momentos. Agradecemos a vossa presença e participação no Ciência 2021.